In this video, we're talking about how to find the scalar equation of a plane, and in this particular problem, we've been given the normal vector to the plane, which remember is the vector that's perpendicular to the plane, and in this case, the normal vector is given by the direction numbers 2, -9, 8, and we know a point on the plane, which is the point P, -1, 4, -2. So we have this coordinate point, and we have the normal vector to the plane, and we need to find the scalar equation of the plane. Well, with these two pieces of information, we're just able to plug directly into the formula because the formula for the scalar equation of a plane is this formula here. What we're going to do is we're going to pull information out of the coordinate point that's on the plane. When we have a coordinate point on the plane, we take the x value from that coordinate point, and we plug it into this formula for the scalar equation of a plane for x sub 0. Then the y value from the coordinate point, in this case 4, goes in for y sub 0 in the scalar equation of the plane, and the z value from the coordinate point goes in for z sub 0 into the scalar equation of the plane. So we take those values, x sub 0, y sub 0, and z sub 0, from the coordinate point that's on the plane. The normal vector gives us the values of a, b, and c. So we're just going to take these direction numbers and plug them in here for a, b, and c. And it's always going to be in this order, like so. And then the last one here, this last direction number, we plug in for C always. So if we have these two pieces of information, we can plug all this information directly into the equation. If we don't have these two pieces of information, we're going to need to use whatever else we've been given to generate these two things. But in this case, it's pretty simple. So what we're going to do is just rewrite this formula for the scalar equation of the plane, but we're going to plug in the information we've been given. So we know A is 2, so we plug that in, and then we get x minus x sub 0, which we know is -1. Then we're going to say plus b, which is -9, times y minus y sub 0, which we know is 4. And then we'll say plus c, which is 8, times z minus z sub 0, we know is -2. And we're going to set that equal to 0 according to our formula. And now it's just about simplifying. So here we're going to get 2 times x minus a -1 is plus 1, minus 9 times y minus 4, plus 8 times z minus a -2 is plus 2, and that's equal to 0. Then we can either leave the equation in this form, or we can simplify further by distributing the 2, the -9, and the 8. So 2 times quantity x plus 1 is going to give us 2x plus 2. -9 times y gives us a -9y. -9 times a -4 gives us a positive 36. 8 times z gives us 8z, and 8 times 2 gives us 16. And then from here, notice that we have 3 constants that we can collect together. So 2 plus 36 is 38. 38 plus 16 is 54. So those 3 together are going to be 54. So we'll have 2x minus 9y plus 8z plus 54 is equal to 0. Sometimes you'll see the final answer given in this form with the constant given on the left side along with the variables. Sometimes you'll see it move to the other side of the equal sign. So you could also give the answer as 2x minus 9y plus 8z is equal to -54. Any of these answers are acceptable, but this is the scalar equation of the plane whose normal vector is 2, -9, 8, and that passes through the point -1, 4, -2.